So we need to talk about possible errors that can happen when you're hypothesis testing. And I don't mean like calculation errors like I accidentally did it wrong. What I mean is when the data is showing you certain things that aren't actually true in the population. Okay, so this type of error, okay, so for example, let's go back to the courtroom setting. Okay, so if the null hypothesis is that someone is innocent. Again, the advantages to the null hypothesis. We believe they're innocent unless they're proven guilty. Okay, so here it does just because we found somebody not guilty does not guarantee that they actually didn't do the thing that they were on trial for. We just might have not been able to see the evidence. Okay, so that is an error. So a jury might say acquit somebody and say it doesn't appear that you're guilty, even though they are guilty. That's obviously not that's not what we went there to do. That's an error. Okay, so there are two types of error. Type 1 error is when you reject the null hypothesis, but the null hypothesis is true. For example, type 1 error would be if a truly innocent person is found guilty. Okay, so if somebody's actually found guilty, but they happen to have been in the wrong place at the wrong time, and the data appears to make it appear like they very, very likely were the person that did something. Okay, so that's called a type 1. It is right here. It is when you reject the null hypothesis, given the null hypothesis is true, this is a type 1 error. And the likelihood that we will make a type 1 error is alpha. Okay, so we get to choose this. We get to choose just how often we would send innocent people to jail. Okay, so this is alpha. Okay, it's called the significance level. 1 minus alpha is called the confidence level. Okay, and it is the probability of failing to reject the null hypothesis when the null hypothesis is true. Okay, so here we're saying we would accept the null hypothesis based on the data, and it turns out the null hypothesis is true. This is a good thing. Okay, so this means no errors happen. So 1 minus alpha, also called the confidence, this is a measure of how often we should be failing to reject the null hypothesis when the null hypothesis is actually true. Okay, there's another type of error. Okay, for example, so here the first type of error would be when somebody is truly innocent but you found them guilty. Another type of error is if somebody was guilty but we can't find the evidence to show that they're guilty. So we apparently let them go free. Okay, so this happens when we reject, there's a little typo here, when we fail to reject the null hypothesis and the null hypothesis is false. So when we quote unquote accept it based on the data, we say, okay, the data appears that the null hypothesis seems to be true. However, the null hypothesis is actually incorrect. Okay, this is called a type 2 error. And it is not alpha or 1 minus alpha. The probability this happens is something called beta. And we're not going to talk about beta too much in this class, but you will see it again a lot in Stat 217. Okay, so this is a bad thing. It's an error. It's a type of error. Okay, 1 minus beta is a good thing. It is called power. So 1 minus beta is called power. And it is the probability that you reject the null hypothesis given the null hypothesis is in fact false. Okay, so this is when you send a guilty man to jail. This is when you let an innocent man go free. This is when you jail an innocent man, and this is when you let a guilty man go free. Okay, in terms of this analogy that we're going with. Okay, so there's 4 different possibilities. 2 of them good, 2 of them bad. You should know alpha and 1 minus alpha, obviously. These things are specified. And in 217, you'll take a really close look at beta and 1 minus beta. Okay, so it's a little bit tricky. It's not talked about in this course. What I need you to know for sure is that 1 minus alpha is not beta. Okay, 1 minus the probability of making a type 1 error is not the probability of making a type 2 error. That is not true. They are related. Okay, so alpha and beta are inversely related, but 1 minus alpha is not equal to beta. Okay, so it's not just 1 minus, it's just not that simple. Okay, so we could actually take steps, if we understand this, to never make a type 1 error. If we never ever wanted to make type 1 errors, okay, remember type 1 error would be sending an innocent man to jail, then the simple solution is never find anyone guilty, ever. We would never be at any risk of finding a type 1 error, of having a type 1 error. That's like setting alpha equal to 0. Okay, again, remember when we were talking about confidence intervals, why don't you have your confidence be 100%? Well, it just means that you get meaningless intervals. Okay, here in a hypothesis test, if you set alpha equal to 0, because you never want to make a type 1 error, it just means that you will always fail to reject the null hypothesis. Don't even bother running the test. Just say the null hypothesis is true. Okay, if you never wanted to make a type 2 error, if you wanted to set beta equal to 0, again, you don't have to run the test at all. All you have to do is just always reject the null hypothesis. Always say the alternative seems to be true. That is what happens when you set beta equal to 0.